5.6, problem solving using rates and proportions. So the main thing in this new section is going to be setting up a proportion. We went over how to solve them in more detail in section 4. So you could go back and look at those notes if that's confusing. I will go through and solve them, but we're focusing more on setting them up. So basically we have a story problem, and for a proportion, if you don't remember what a proportion is, that's where you have a fraction equals a fraction. That's a proportion. A ratio equals a ratio, or a rate equals a rate. And the main thing for setting this up is it's important to make sure you keep the same things in the same spot. And I'll show you what I mean in number 1 here. So we have a young raccoon has three tail rings on a 6-inch tail. If the spacing doesn't change, how many rings are on a 14-inch tail? So we have two different things. We have the number of rings and we have the length of a tail. And I'm going to write it like this because the main mistake that I see are people get those in the wrong place. So if I put rings on the top and the number of inches in the tail in the denominator, now I can set up my proportion. But what I mean by this thing here is that I need to have rings on the top in both and inches in the denominator in both. And I could totally flip that over if I wanted to and flip this fraction around to the reciprocal, and then I'd have like inches in the top and rings in the bottom. That's fine as long as you have the same thing in both tops, same things in both bottoms. Okay, so I like putting this thing here on the side because if I have that, then it's real easy for me to, all right, they always are going to give me a pair. So I have 3 tail rings, so 3 rings goes on top, and a 6-inch tail that goes down below. So those two are connected together. Now, if the ring spacing doesn't change, how many rings are, so we're looking for a number of rings, so X has to be up here where we have rings, and then are on a 14-inch tail. Does that make sense? Yep, because 14 is 14 inches, and that's inches. Now we go back to what we were doing in section 4, and we cross multiply and divide. So I have 6 times X equals 3 times 14, kind of that other way. And then 6x equals, that's going to be 42. And now I take and divide both sides by 6. Divide both sides by 6. So then x equals 7. And it's 7 what? Well, x is up here in the numerator. The numerator was rings. So that means that this raccoon is going to have 7 rings on his tail. And I would like you to show your work. It's just a lot more likely to get them right if you actually set up your proportion and go through and do your work. So please show your work on your homework. It will only take you a tiny bit longer perhaps than doing it in your head. Okay, the next one then, let's switch to this one here. One of Mr. Falk's bikes gets 2 flat tires every 430 miles. So we have number of flats and we have number of miles. And it doesn't matter which ones you put on top as long as you always keep it there. So I'm going to do flats on the top because they listed it first, miles in the denominator. And if I set up my proportion, all right, 2 flat tires. So if it's number of flats, it has to go in the numerator. 430 is miles. That goes down below. And those will be part of the same fraction because they're the pair, 2 flats every 430. Now, they're going to have to give us one of these 2 things, and then we'll solve for the other one. So how many miles does he go over the course? So how many miles? We're looking for number of miles. That has to be down here then. So x in this one is in the denominator, where in the first one is in the numerator. So how many miles does he go? That's x, over the course of having 7 flat tires. So if we did everything right, 7 will make sense up here, and it's 7 flats, and yes, flats are in the numerator. So there, we have it set up. Now we just go back and solve it like we have been doing all along. So solving it, well, I cross multiply, so I have 2 times x equals 430 times 7. So I get 2x equals, punch that into your calculator, and you get 3010. All right, now I'm solving for x, so it's x was multiplied by 2, so I'm going to do the inverse. I'm going to divide by 2, and x equals 1,505. And 1,505 what? Well, that's my x value, which is the number of miles. So in theory then, I can go 1,505 miles and have 7 flat tires. That's pretty awful. Need new tires. All right, if Jonathan can throw a disc golf driver 137 meters in 1 throw, how many throws will it take him to go 436 meters? So we have a number of throws and we have a distance. And again, you could do throws over meters. You could do meters over throws. I'm going to just stick with throws over meters. And once I label that, and again, please go through and actually write this. It only takes a moment, and then you're more likely to get this part here correct. So, all right, so they have to give us a pair. And we have 137 meters and 1 throw. It's a little tricky. Some people miss that because it's typed out. So 137 over 1. Oops, I totally did that wrong. Let's erase that. So it's, all right, it's 1 throw. So that has to go up here. And the other way to do it, if you don't want to write your units over on the side, is you could go through and write in 1 throw and 137 meters. And then do the exact same units over in your other fraction. So throws and meters. I'm kind of trying to skip that step by writing it over here, but this is perhaps even a better way to do it. So how many throws will it take him to go 436 meters? Well, 436 isn't number of throws, it's number of meters. So 436 meters. And then the missing thing of those 4 numbers is going to be the number of throws. So how many throws does it take to go 436 meters? All right, and then we're going to go through and cross multiply and divide. So I get 137 times x equals 1 times 436. So I have 137x equals 436. So if we're trying to get x by itself, well, what did they do to it? They multiplied by 137. So we'll do the inverse. We'll divide by 137. If I punch that into my calculator, I come up with 3.18. And 3.18 what? Well, it's 3.18 is my x value. So that's the number of throws. So in other words, on his 3rd throw, he won't be quite there. So you'll have to throw a little bit more. So it'll take him 4 throws total to go that distance. And you could, I suppose, write out 4 throws. But I'm going to go with a 3.18 because then I can tell you actually knew the answer. You came up with it. It's a little more than 3. So that's it for this section. Main thing is either put your units here on both of the fractions. That's probably the best way to do it. If you want to be a little bit more of a slacker, you could just write them one time over on the left. That's all I got. Let me know if you have questions.